frameworks that are available to you to use in the browser. And then once we understood how the browser works, we understood jQuery and all those things, we then moved on to the server. And the way we covered the server there is by looking at Node.js. And as you saw with Node.js, unlike Apache, you have to do a lot of the configuration yourself. So the routing, for example, that you might get for free from Apache is something that you explicitly have to do in Node. And then we looked at Express, which is a framework that makes this kind of behavior easier. And then we also discussed how Node behaves as far as non-blocking I/O, right? Comparing it to blocking I/O that exists in, say, Apache and some of the other servers. So we understood the cost and benefit of using Node.js. And then we moved on to a database, specifically MongoDB, which is a database that's very different from your traditional relational database. It's a NoSQL database that just stores basically JavaScript objects. It's very easy to use, it's very scalable, has MapReduce, which is another thing we covered. And by understanding MapReduce, this really core concept of how MapReduce works, or how to at least write map and reduce functions, we're now able to move to Hadoop, which has the same notion of MapReduce. We're now able to move to other NoSQL databases, which also very often implement MapReduce. And so once you understand MapReduce in Mongo, you can now use this understanding to write MapReduce for many other databases. And that's great. So at this point, we really kind of have an end-to-end understanding of what it would take to build a web application. Everything from the client architecture, all the way to the server, all the way to the database, the full application stack, if you will. Which is really great. That means you guys are at this point equipped with the tools that you need to actually start writing end-to-end applications. In other words, you no longer need someone to write the server code so you can do the client. Or you need someone for the client so you can do the server. Or you need someone to write the database queries because you don't know how. You now understand the full spectrum. Now, I understand that at work, in reality, most of you probably aren't necessarily doing end-to-end work. Some of you may, but many of you, I understand, are front-end engineers or sort of, middleware server engineers, or some of you are, database experts. And I understand that, and that's okay. But I also think it's important to understand the full spectrum before you dive into anything specific, right? Because it will help you better understand the context in which you're working. So that's kind of where we are today. And so I thought for the last meeting, I would cover sort of two topics. I'll quickly go through some performance things having to do with the browser and sort of serving up web applications and that kind of thing. This, I think, we'll go through pretty quickly because I'm guessing, they're small, they're like quick tips, and there are a few of them, so we'll go through them quickly. And then we will dive into something that I think is probably the most important thing in software engineering. Well, it's a loaded thing I just said, but I actually think this. And that's the ability to write clean code. The reason why I think it's so important to write clean code is because, well, I'll go through the reasons, but one of the things I hope to convince you before you leave today is that getting an application to run or getting an application to work is just half of what you need to do. Okay? It's not enough to just write code and say, look, it works. And people go, oh, and then you're done. It's really not enough. The quality of the code that you write that drives the application that you see is just as important. In fact, in my opinion, it's actually a little bit more important. And I'll try to convince you of that as we move forward. So, does anyone have any questions or comments so far? Okay, so let's dive in. Okay, so we're talking today about web application performance. And so when we talk about web application performance, we're really talking about three things. We're talking about network, compute, and render. So network is the traffic, it's effectively what you're using to download data. Right? So it's the speed at which content goes from the server to the client. Compute is any kind of computation, whether it's JavaScript or whether it's flow. If you guys remember what flow is, it's figuring out the geometry of where things are to be rendered on the screen. And then render is the actual sort of putting it into pixels and putting it onto the screen. Right? So the question is, how do you optimize each of these three things? So we begin with network. And so by network, what we're really talking about is minimizing the payload that we're getting from the server in order to decrease the round trip time. By round trip time, I mean sending the request and getting the response. This is the round trip, okay? Going all all the way around. And so what are the things you need to do? Well, one thing that I hope all of you do in your web applications is to turn on gzip. Okay? What gzip will do is any of the requests that are being sent from the server will get compressed, and then the client, when it receives the request, will deflate it. In other words, will unzip the response. Okay? And so obviously that will minimize the payload, and the smaller the packet, the quicker it gets. Right? The less stuff you're streaming in. So to enable gzip in Apache, you do a few configurations. To enable gzip in Express is actually a little different. It used to be express.compress. So what am I doing here? Can anyone tell me? App use. What am I adding here? Yeah, I'm adding a route. If you remember, when something comes in, it goes through a bunch of routes, right? You guys remember this? So this is just another route, except you add it typically at a place where the file is getting streamed out, and this will basically, when it goes through this route, compress the stuff that's inside of the request attribute object. That's the first parameter that gets passed in, if you guys remember, to that function. The function gets a request, a response, and a next. That request, sorry, not the request, the response is where you will put your file, and then if you run it through this, it will then compress that file before it sends it. Okay? So if you do app use, you don't do express.compress anymore. A compress is now a separate module that you npm install that, and then you just pass it in. So it's one line to add compression to your Node application, one line. And I encourage all of you to do it. Okay, CDN. What is a CDN? So what a CDN is basically there are lots of repositories, so Google has it and lots of other sort of big companies have it, where they store commonly used libraries, like jQuery and Angular and Backbone, things like that. And I recommend that you use these CDNs. Why? Because here's why. The best way to decrease round-trip time is to have the round-trip time be 0. Would you agree? Okay. So the best way to decrease the amount of time it takes to go to the server and come back is to not go to the server. How can you avoid going to the server? Cache hit, exactly. You hit the cache. So how can you hit the cache? Well, one way to do it is if you reference a CDN that another application is also referencing, that means that other application has already downloaded that file, and you are now getting a cache hit. I'll give you an example. You guys probably use Facebook, Google, and all these different apps, right? I'm guessing that some of these, at least one, probably uses jQuery, right? If they are referencing a jQuery in the CDN, and then my application comes in and says, I need jQuery from that CDN, that's a cache hit, because the other application already downloaded it. You guys see what I'm saying? Okay. So using CDN will simply increase the probability of you getting a cache hit because you are sharing the same reference as other applications. And so while another application may get it and download it, you may get it and get a cache hit right away. So CDN is great for improving performance because it increases the probability of getting a cache hit. Okay, so there are a few sort of traditional ways to use a CDN. One thing that I'll tell you is you should never sort of depend on a CDN. So if you think about it, a CDN is an external server, right? That you're referencing to say, download this library from over there. Now, what happens if that server over there happens to crash? Suddenly, your application is dead in the water. So depending on an external server is kind of dangerous. It's good because it increases probability of a cache hit, but it's bad because you now have a dependency on someone else, and if they shut it off, or they remove it, or they do anything, suddenly you're dead in the water. You have a problem, right? So the question is, well, how do you solve this problem? Well, there are a few ways to get around this. So one way is to do something like this. This is the very simple approach. So here I create a script tag where I'm referencing some jQuery inside of the Google CDN. Okay? But then, if you notice, underneath I have another script tag. Now, if you don't put any weird attributes like async or something, what will happen is this will execute first, and when it's done, then this will execute. Okay? So it's actually a sequential operation. Why is this interesting? Because what this means is that after I call this, here I can write a script tag where I do window.jQuery. What am I doing here? Exactly. I'm testing to see if this is truthy. If this is truthy, it's returned, right? Because this is using the OR, right? If it's truthy, it's returned and we're done. If it's falsy, we go to the next one. You guys remember this? Okay. So we go to the next one. What does the next one do? It does document.write, and it puts in another script tag. It puts in a script tag that has the source, where the source now is to my server. This is to my internal server. So the idea is that this is a backup. If this fails, you can use your local version instead. Okay? There are a few other approaches to this. There's a library called yip nope. It's like yes, no, yip nope. Where for yip nope, you give it a load, which is this, and then when it completes, you can basically test to see, well, has jQuery loaded? If it hasn't, you can call yip nope again. And the idea is that can then also have a callback function, which then you check, and then you can do another yip nope, and so on and so forth. This is not used nearly as much as the last one I will show you, which is require.js. So we haven't really covered require.js here. But basically, let me just say a few words about what require.js is. So in JavaScript, we have no inherent way to break up our code and import it from different places. The only way we can do this is to put it in different files and put in a bunch of script tags. Right? But for those of you who have done any Java, for example, with Java, you create your various files, or your classes, or whatever, and then you just do import, right, at the top, where you import all the different, it's import, right? Yeah. So you import all the different files, and then that file can import files, and then that file can, right? So you make your dependencies within each file. And then Java will then figure out what each dependency is for that file and make sure that that's linked on, when it's interpreted. And then everything runs, right? There's nothing really inherent like this in jQuery, in JavaScript. At least not right now. In the future, we will have this behavior, right? There are future standards that are coming that will allow you to do this. But right now, we don't have it. So we need an approach, right? Because we're building applications today. We can't wait until the standards come around later. So one sort of thing that people have come up with is this thing called AMD. It's called Asynchronous Module Design. Design? Yeah, Asynchronous Module Design. That's right. Okay, so what AMD is this way of structuring your code so that it can be easily loaded by other files. Okay? And require.js is a library that will allow you to use the structure. Okay? So in other words, just structuring your code like that isn't enough. You then need a library to actually load that code. So require.js is that loader. Okay? In fact, require.js actually has two global functions that it contributes. It contributes a require function, which is kind of like your import in Java. Right? Well, this is where you can say all the things you need, and then when they're all loaded, it will call you and say, okay, go. It also has a declare, which is where you make a new module. Okay? So you can make a module, you can also require a module. Okay? All of that behavior is inside of require.js. If you didn't quite understand some of what I said, that's okay. I recommend that you do go and read require.js, some of the documentation, and maybe even use it. So with require.js, one of the things you can do is you can specify a configuration object. And in the configuration object, you do all kinds of things that I don't want to go into, but one of the things you can do is you can specify a local name to the actual path. So that when you import, okay, think of it in Java terms, import, you don't have to give it the entire path to the file, you can just give it the name, and that name will hash to the actual URL. Okay? So it knows where to load it from. Well, it turns out in require, you can not only just specify the name to the URL, but you can do the name to an array. And in the array, you give it a list of all the URIs, and what it will do is it will first try to load the first one. If it's success, good. If it fails, it loads the next one. You guys see? So with jQuery, I can have the first one be a CDN. If it loads, great. If it fails, it goes to my local version. Okay? Questions on this? Okay. So images. So this is a huge thing. I'm sure many of you guys kind of can guess this, but images take up a lot of space. Right? If you actually look at all the stuff that you're downloading into your web application, right? Most of the biggest things that you're downloading are typically images. It's not code, it's not CSS, it's usually images. Images are huge, okay? So we need to be very careful about how we use images. So first of all, you want to make sure that you compress your images properly. There are various compression algorithms out there. There's, GIF, PNG, JPEG, etc. And I've seen lots of websites that will say, if you're compressing this kind of image, use a GIF. If you're compressing this kind of image, use a JPEG. In reality, I found only one way to actually know which is best. Can anyone guess? Huh? Best thing, yeah. You run every one, you compress your image in each one of them, and you see which is the best. That is the only way I have found to actually get the optimal result. Otherwise, you're kind of guessing. And there's no algorithm that will tell you for sure whether this image is this way, except if it actually runs every one and tests. Right? So I recommend you do that. Second thing I recommend is images. When you take a photo with your camera, right, your beautiful camera, right, it adds a bunch of metadata to that image. It adds what camera was used, when the picture was taken, and a whole bunch of other statistics that I don't even know about, right? This is all stuff that's added to the image size. So when you're downloading an image, you're downloading the image, the pixel information, along with all of that extra metadata, which is adding bulk. So there are lots of algorithms out there that will go through and actually remove anything that is not 100% necessary to view the image. I recommend you run your images through these algorithms so you get the maximum, or the smallest image possible, okay? So again, to improve network traffic. Yeah, so this is what I'm saying. So there are lots of tools available to do lossless compression. There's a JPEG trend, there's JPEG, whatever, just Google. There's lots of these, okay? I'm sure there are even better ones now. I made this slide a year ago. There might be better ones today. Sprites. Who knows what a sprite is? Woo, John. All right, good. All right, then we'll go through this quickly. So sprites, the idea is this, that tests have been done, and it seems that if you download a lot of small pictures, one at a time, it actually takes much longer than to download one big picture that inside has a lot of small pictures. Okay, let me say that again. Downloading small pictures, like 50 small pictures, will take longer than downloading one big picture that has 50 small pictures inside. Okay? So that's what a sprite is. That's all a sprite is. It will take, so in this case I have, let's see, what am I doing here? Okay, so this is a sprite. So this is the actual image, right? If you know, remember I said 50 small images in a big image? So this whole thing is an image. It's one image that happens to have 1, 2, 3, 4, 5 small images. And what I can do is, if I want to render dog, I can basically take this image, set it as the background, and just shift the position so that the dog is the part that is visible in that area. It's basically a trick, okay? So that when you have a big image, you can only show one part of it. And the idea is that if you then want to show camel, you simply change the offset, and now you're seeing camel, and so on and so forth. Okay? So when you can, download one big picture instead of lots of small ones. That's all that I'm saying here. There are tools that will help you do this. One of them, one popular one, is this. It's a website. You go to it, you basically upload all your images, and it will give you back one sprite with the CSS. That's the cool part. So you don't have to guess what the offset is and how to shift CSS around. It will tell you. It will give you the CSS. Another thing to do is to use like something, so you remember I mentioned Grunt, which is kind of this build tool that will allow you to do step-by-step execution of some process. Well, there are plugins for that that will build sprites for you and generate the CSS. And then you can take that CSS, add it to the rest of your CSS, compress it, and deploy it. So lots of approaches to do this. Which approach you pick is kind of up to you. responsive design. Okay, so so the idea behind this is this. If you build an application, right, you want it to, let's say, work in both big screens and small. But if you think about it, if you set like an image inside, right, the images that you will need for something like this will be much different from the images you need from something like this. You guys see what I'm saying? If you download a huge image for something like this, it's stupid to download the same exact image for something like this, because you don't need it. All you're going to do is resize that big image back down. In fact, watch this. Downloading bigger images than you need actually comes at a huge cost. First of all, there's the network delay, right? Because you're now downloading a big image. Then you have to resize it. Resizing an image is not trivial, guys. That's actually a good amount of math. All those pixels have to be recomputed to figure out what is the smaller version of the original. So you're adding both network and compute overhead by downloading a picture that is bigger than what you actually want to render. So the idea is, when you're rendering an image, understand how big you want that image to be, and only download images that fit that size. No more. Okay? Anything more is adding additional weight that you don't need. Okay. So with responsive design, one way you can do it is you can use, so for those of you who don't know what this is, in CSS you can basically put if statements. It's basically what it is. It's kind of an if statement. It's saying this, that if the screen size has a maximum width of 400 pixels, then execute this. Right? If this, execute that. If that, execute that. Okay? It's basically what it's saying. That's what effectively media query is. So what you can do is you can choose the appropriate image. So you can have a different image here from an image here from an image there. Okay? That's one approach. Another thing to use, so this is a library. This is an external library that you can actually download. And what the library will do is you specify your images not in image tags, because if you specify image tags, it will automatically just download it. Right? So that doesn't work. Instead, you specify it inside of this data source, inside spans. And what this will do is it will effectively download the right one. Basically, it will pick the right one, convert it into an image tag, put it as the source, and the thing will render. See that? Okay, that's another approach. Okay, anyway, so just be careful about how you use your images, because typically they're the biggest piece in the puzzle. Next thing, minify JS and CSS and HTML. So a lot of people only talk about minifying JavaScript. HTML also needs to be minified, guys. When you write HTML, you put in comments, you put in all kinds of additional spacing that is just ignored by the browser. All of that needs to get removed. You don't need any of it, right? So get rid of that. Same thing with CSS. When you put CSS, you're doing a lot of the things that you're doing is formatting, right? You're adding all this extra space, right? You're putting semicolons in the last expression that you don't need. There are all kinds of things that you're doing that you don't need when you're actually running it. So run it through a CSS minimizer. Duplication. Duplication is evil. This is going to be part of the next piece that we'll talk about. Die. Duplication is evil. So what do I mean by this? Well, think about it. So first of all, when you duplicate code, there's the fundamental problem of if you now find a bug in that code and you fix this one, you still have a bug, right? So duplicating code is not a good idea. Just programmatically speaking, it's a bad approach. We all know this. The problem is it's also bad when you're talking about network traffic, because now by copying and pasting something, you've just now duplicated the size of your code, right? So don't do that, right? Avoid duplication. Avoid copying, right? Keep code where it is, put it into a function, reuse it twice. That will make your code a lot smaller. Okay, this is something that many of you may not know about. You can actually omit the protocol. So you know typically you do like HTTP : / blah blah blah. You can just do // This is actually better. Not only is it better because you're using less stuff, right? The code is smaller. But it actually, supposedly, and I need to read more about this to understand exactly how, but it actually improves caching. By the way, does anyone know why it improves caching? Okay, no. So all of us have some reading to do, but it does. So Google recommends that you use this rather than this. You get it? So you just omit this first part. You just don't need it. Okay, so that's one bit. This is another one that many of you, John. Ah, there you go. HTTPS or HTTP? Gone. Alright, so this is one that a lot of you, I'm guessing, didn't know. You can actually omit, you know this stuff where you do HTML, head, body, you guys know that stuff? Did you know that you don't need it? This is completely legal. This is the same thing as this, but this is way less code than this. And this is perfectly legal. Just keep that in mind. It should be. I mean, it's legal. If you look at the standard, the W3C standard, that's legal. So unless you have a bad validator, it should be legal. Right? And any browser will run that code just fine. Yep. Okay, so it actually doesn't matter whether you... Okay, so let's go here, right? You're saying include the CSS here, right? It actually doesn't make a difference if you include it here or if you include it right there. At the top, at the very beginning of your body, right here. In fact, this is bad, you don't do this, but you can actually even put it here. This is illegal, right? It doesn't, but if you did it, it would work. Don't do that, though. So you can either put it here or you can put it here. It actually doesn't matter. Because what happens is, if you think about it, all it's doing is executing top-down. That's why you put your JavaScript at the bottom and your CSS at the top. Except typically, since you're already grouping things by body and head, people recommend to put it inside of head, so make sure that it's above the body. But if you put it at the top of the body, you get with the same result. You see what I'm saying? Because the order is the same, right? In German? Put it at the very top. Put it right here. By the way, I should tell you this. Even though I know this, I still do this. And I do it for the following reason. Not because this is better, not because of anything, but I do this because I don't want to confuse other engineers. I'm serious. I did this once, and an engineer came to me and said, sorry, Rouben, did you, what are you doing? And I thought, okay, I took the time to explain it to him, but I didn't want to keep having this problem, right? So I decided, since most people understand this better, the benefit of people being able to read the code versus the trade-off of writing it, of making it smaller, I figured that I might as well do something that people know. But I want you guys to know about this so that if you see code like this, you don't get confused. This and this are actually the same. This is much.
Response to John to this header state of body. I think I already pushed the body code.
So this is what I'm saying. It actually doesn't matter. So the reason why that happens is because the thing is executing top down. And if you don't, so in this case, head is above body, right? So it's executing this and then this, right? So all you're saying is this first, this second. Here, this first, this second. The order is still there.
But header może HTTP protocol, to jest header to no body, czy?
Yeah, but all
server na my this is header link header body wasn't redirect header and body.
Wait, header and head is not the same thing.
But web server header
Yeah, but again, header is the thing when you send a packet, right? At the top you have some metadata about what the packet contains, and then the actual information that's getting sent, right? The payload, right? You're with me so far? Okay. That header that's there is not the same as this. This is actually part of the payload. This is content. This is the text that's being sent to you, which then has header information that describes information about the content in the packet. Do you see what I'm saying? You understand, right? So this is just HTML. That has nothing to do with header information. Header is part of the packet that's being sent to the server. Հասկանու՞մ եք ինչ եմ ասում։
Նախորդ օրինակում այդ
Նախորդ
URL-ի
Ասում սերվերը ոչ չի տա։
Որ օրինակ։
Այստեղ եթե HTTPS-ը, ասենք, domain-ը HTTPS-ի տակ աշխատում, եթե հիմա HTTP չգրենք, կարող ես պետք է կոնկրետ այդ ֆայլը HTTP-ով կաշի, եթե մենք կարճ ենք գրում, ինքը ավտոմատ HTTPS-ով է փոխվում կաշի։
Ինքը ոնց է resolve անում, ճիշտ ասած ես չգիտեմ։ Անձամբ ասում։ Անկեղծ, անձամբ։ Ասում եմ։ Չգիտեմ, բայց գիտեմ, որ կաշխատեմ։ Ու բանը, հա, եթե դուք ասում եք, եթե համեն կա համեն որն է որոշում, եթե համ HTTP վարիանտը կա, համ HTTPS-ը վարիանտը կա, դա ձեր հարցը։ Ի՞նչն է ձեր հարցը։
Մենք երբ որ գրում ենք HTTP, ստիպում ենք, որ HTTP-ով չեք քաշի ինքը։ Այդ կոնկրետ ֆայլը։ Ամբողջ HTTPS-ով, բայց այդ ֆայլը HTTP-ով է։
Այդ չեք կարող, այդ security բանը, exception կտա չի թողնած։ Հակառակը կարելի է։ HTTP մեջից HTTPS կարելի է։ HTTPS-ից մեջից HTTP չի կարելի։ Չէ։ Խոսք եմ դա, փորձեք։ Հենց հիմա պրոյեկտ եմ անում, որ գիտեմ հաստատ չի կա։ Ասեմ ինչի։ Okay, so the question is what happens if you make an HTTP request from HTTPS, right? So think of it that let's put technology aside and just think of it as a user, right? What is HTTPS? HTTPS is a promise, right? It's a promise from the web application to you, the user, that it is going to be a secure environment, right? It's going to use SSL and all that good stuff, right? So if it internally makes an HTTP request, HTTP is inherently not secure, right? So the promise that it's making that it's going to be secure is being broken by the fact that they just made an HTTP request, which is why browsers actually don't allow. They even if you try to put in an iframe and you have the iframe to HTTP, even then it doesn't allow it. I mean, I can tell you for sure. I've tested it on Chrome, Firefox. I've tested it on IE. I've even tested on the older IE, and they put a patch in that. I think they used to allow it, but then they put a patch that says you can't do it anymore. Because it breaks the promise. It allows people to do insecure things inside a secure container. But the opposite, you're right, you can. If you have an HTTP container, if the website is coming from HTTP, and then inside of that you make HTTPS, that's okay. Because there's no promise. You see what I'm saying, right? Because there's no promise there. So, yeah, absolutely. Cool. I haven't tried. So the question is, will this work with FTP? I don't know. It's worth a try. I've never tried it, so I can't tell you. Has anyone tried it? No one? Okay. Well, we'll see. We'll try it sometime. Okay. How's our notes? IE8 you mean? IE6. IE6. It should. Tell you what, I'm pretty sure that it does, but I haven't tried it. So try it, and if it's not, can you post on the Facebook thing so we know? But as far as I'm concerned, I think it should because it's part of the standard. So, so that's a bad assumption too, because IE6 doesn't necessarily stick to a lot of the standards. So, good? Alright, so next one is very simple. You can actually omit a lot of the tags. So for example, you guys see this, rel style sheet? You don't need that. That's extra. It knows it's a style sheet because of the header information that comes from the bottom. The same thing with your script. You guys remember this? Type, text, JavaScript? You don't need that either. Because when it loads the thing, it looks at the MIME tag that's sent to it inside of the header, and it understands that it's JavaScript. It doesn't look at that. So all of this is extra. Just do that, and it's much smaller, simpler to read. Always good. Sorry, I meant this. Okay, so type is the attribute you don't need. Okay, for both. You don't need that, you don't need that. Sorry, you're right. This I comments. Okay, type is what you don't need. Use the others. Okay. That's it. Okay, so this is an important one. This, let me scroll up so you guys see it. This does the same exact thing as that. I think you guys get my point. If you're writing CSS, get good at it. And write shorthand CSS. This is easier to read and it's smaller to download. This will take longer to read and so I think is harder to read and will take much longer to download. Make sense? Good, so do that content. I didn't quite, wait. If you want to export an HTML into PDF, is that your question?
Depends on library.
But it depends, yeah, but that's a library that you're using, right? You're giving it to some library that will process it and return. If you're using a library that supports an explicit left but not shorthand left, you're probably using a bad library. I'll tell you this, because here's the thing. The library itself shouldn't be writing CSS parsers. It would probably use an off-the-shelf, like there are Apache parsers, for example, that they can just use, that will support the whole spectrum. And what does a parser do? It returns a parse tree. Remember this? You give it a language, right? You can also give it grammar and all that stuff. It returns a parse tree. And once you have a parse tree, you understand all the specifications. And then using these specifications, they can read that and then draw the PDF. See what I'm saying? Okay? Other questions? Okay. Right, so you should write compressible JavaScript. So what do I mean by this? Well, first of all, avoid global variables. So no, you can have your global variable be this big, and you can never compress it. Because it's global, right? It's in a global space. That means you don't know all the different things that can load that will need to use that. And if you change it, suddenly you load a library that tries to read it and can't find it because you changed the name. So that's another reason not to use globals if we don't already have enough. Remember I kept talking about how instead of using this, you can actually create a var that, set that to this, and then use that everywhere? So again, this has two benefits. One, it's compressible because that can turn into A. But also, you don't make this mistake where if you have an anonymous function, you use this referring to window, or if you're running in strict mode, get undefined and then get errors. Instead, you just use that and you're done. Okay? So just remember that conversation about that. Study jQuery? Native is always faster than any library that you use. Always. So what, in fact, if you read the code in jQuery, a lot of times they will, if it's a request that native can handle, they will then call native. A lot of times. So they try to leverage the native code as much. Only if native doesn't support it, then they do their algorithm. But the problem is, even that level of indirection is still slower than just going direct, right? But again, it's a trade-off, right? But the benefit you get is that it works cross-browser. So take your pick. By the way, the reason why I say study jQuery is because the people who wrote jQuery spent a lot of time, or who are still developing jQuery, are spending a lot of time making jQuery as small as possible. In other words, making it compressible. So if you look at, so for example, this trick that they do where they pass in window as an argument to the big function that they wrap it in, and then they use a local window, which can then take that window variable and compress it into A. That's another trick, right? They do a lot of these kinds of things all over their code to make their code compressible. So if you want to understand what's a good approach to writing compressible code, read the jQuery source. Okay, it will teach you a lot. Okay, so we talked about the, minimizing network traffic. Let's talk about minimizing computation. So remember that the browser only has one thread, right? Because it has one thread, be careful how you use it. Because if you use it too much, it will freeze the browser. Okay? So suppose you have to write some sort of a complicated algorithm on the browser. What can you do? Well, one thing you can do is just run the algorithm. But the problem is, remember, there are no interrupts in JavaScript, right, in the browser. So if you have some thread of execution and it's now running your complex compression algorithm, right, everything else is frozen. The screen is frozen, the buttons are frozen, you can't click anywhere, you can't do any, the browser is just frozen. Until the algorithm actually completes, finishes, and now the next thing can be scheduled to execute. This is a big problem, and this is the same problem with Node. Remember the example that I gave where the customer said, I want beer, chorobats, and 50 push-ups? And the waiter is now doing 50 push-ups. Remember that example? It's the same problem. If you do too much computation, you're freezing the browser. Or you're freezing Node. Same problem. So the question is, okay, how can I write code that is very complicated and is doing a lot of processing, but not freeze the browser? The answer is to break up your algorithm into pieces and execute each piece with a set timeout in between. Okay? So you do a piece of your code, and then you do set timeout so other things can run. And when the set timeout callback function is called, it continues the next step. And then set timeout again, something else happens, comes back, set timeout again. Think of it this way. In multi-threaded programming, right, you get interrupted when the manager says so, right, when God says so. Right? You have no control over when you get interrupted. Right? You just write your code, and at some point someone interrupts you and schedules someone else. In this kind of environment, it's your responsibility to interrupt yourself. Okay? And the way you interrupt yourself is by doing a set timeout, which releases the thread, allows other things to execute, and then finally, when they're done, calls your callback function, which continues the rest. You guys see this approach? So let's actually see some examples. So this is an example of freezing UI. So watch this. When I click on the button, did you see how the button stayed gray for a while? Okay, let me increase the size by something much bigger. Ready? Watch this. See? Look, the browser's frozen. I can't click. I can't do anything. Finally, when the computation, now I can. Now I can actually see when I mouse over it. I can click on this, and now it's frozen again. Frozen. Now it's not frozen. That time, while the browser was frozen, I couldn't do anything. I can't click. I can't type. Why? Because this for loop is running, executing, freezing everything until it's done, and then I finally get the result. So this is an example of a bad design, right? This is executing too much algorithm without interrupts and freezing the entire UI. That's not a good approach. Okay, so what's a better approach? Watch this. See? Did you notice how start went immediately? So start, just so you guys understand why you're looking at the start button. When you click on it, it kind of changes color and then changes back. It's like the click. Okay? If it freezes, it never goes back until it finishes and then it goes back. With this, did you notice the moment I clicked on it, it went... Let me do it again. See? Okay. So what's happening here? Again, what we're doing is we're breaking up our algorithm into a set timeout. In this case, the algorithm is breaking down very granularly, where every time we're incrementing I, or we're rendering I, we're doing a set timeout. So for each iteration, we're doing a set timeout. The problem with this, of course, is that we've gone too far the other way. Now our algorithm will just take way too long. Look how long it took me to compute 100. Whereas with the previous one, I was calculating, like, how much? Something much bigger, right? Look at that. Right, so that's 999,999. Look at that. 1 Mississippi, 2 Mississippi, 3 Mississippi, 3 seconds-ish, right? Mississippi is 1 second. Okay, so whereas with this one, look, 1 Mississippi, in 1 second we compute 100, in 3 seconds we compute 999,990, right? So, okay, so doing a set timeout on every iteration is not a good way to break up our algorithm. Okay? So what you need to do is break up your algorithm more intelligently. One thing you could do, for example, is to put in a for loop here that will execute the next 100. It will execute the 100, and then it will set timeout, and then execute the next 100. Or 1,000 at a time. Do 1,000, set timeout, come here, do 1,000, come here, right? Don't just do 1, 2, 3, 4, but instead do 100 or 1,000, 1,000, 1,000. That way you're jumping 1,000 at every iteration. Do you see what I'm saying? So how you break up your algorithm, how much work you do before you do a set timeout and then you do more work, is entirely up to you. That's up to you. Okay? So there is... Okay, so this is a utility that I wrote like 4 years ago, I think. It's kind of long and complicated, but it's not that complicated. And what it allows you to do is it allows you to do this kind of set timeout, but based on time. So here's what you do. You break up your algorithm into a function. And every time your function gets called, it executes the next step. Okay? Now, how often that function gets called is based on the timer. So the idea is this. Imagine that function for the previous algorithm is incrementing by 1. Okay? What I would do is I would feed the function to my runner, and it would execute that function over and over, no set timeout, just execute the function every time until a certain amount of time has elapsed. And then it will set timeout. And then it will call it again until the next time interval is elapsed, and then it will set timeout. And then it will execute that way, and so on and so forth. That way, you're not just putting in an arbitrary execute 100 times and stop, or execute 1,000 times and stop. Now you're actually using the time that it takes to execute as the thing that decides when it needs to get interrupted. Okay. If you don't get this, it's okay. But this function, it's kind of long and complicated. So it's online. It's actually not that complicated, actually. Feel free to read it. Ask me questions about it. No problem. Right? Email me. Find on Facebook. You know the drill. Okay. So that's what that does. Correct. Start. So you can see it's slower than the first one, which froze it, but it's faster than set timeout on every iteration. It's the in between. Okay. Cool. All right. So you can use this utility however you like. Hack it, modify it, whatever. Okay. We have this notion of web workers. So this is part of the HTML5 spec. And what it basically allows you to do is, so you have your actual thread, which is your browser thread, right? You can set up a separate sort of execution thread. Okay, so this is where things get tricky, because you're going to say, well, I thought there's one thread. Yes, but this is a way to make another one. Okay? Now, with multi-threaded programming, one of the biggest things is shared resources, right? Because you have a thread here that's modifying something, you have a here modifying something, and you can have a thread race, and they can modify in different order. Right? Shared resources are one of the biggest problems in multi-threaded programming, right? So the way they solve this, so they didn't want to have this problem, is you have to, in order to send anything from here to here, you have to send an explicit message. There are no shared references. You can send a value, but you can't send a reference. That means if something is modified here, it doesn't get updated here until it explicitly sends a message saying, here's the new value. You guys get that? So it's a message passing system, and here's how it works. So first, let me show you the demo. 1 bottle, 2 bottle, 3 bottle, 4 bottle. So the execution of computing the bottles is happening on a separate thread, but the rendering of the result of that is happening on the main browser thread, which is rendering this. Okay? So let me show you the code. It's very simple. So you want to make sure that workers exist. So here it is. And then what we do is we create a new worker and we reference this file. Okay? This is a separate file where the worker code is being written. Then what you do is you say worker on message. What do you suppose on message is? It's when you receive a message from the worker. Okay? So this is where you receive input or messages from the worker to us. And this is where you post a message to the worker. Okay? So here you're sending something to the thread, and here you're receiving something back. Okay? All right, so what are we first sending something to the thread? We're sending text. We're sending bottles of beer. And what the thread will do, the algorithm of the thread, is it will pick a counter, and it will append the counter to this text. So if I were to change this bottles of beer to J, and then run this, I'll get 1 yay, 2 yay, 3 yay. You get that. Okay? Then what we do is, as we're receiving results from that, from the other thread, from the worker, we will simply print, do hash result, which is the element that's up there, inner text, the result that comes back from the worker, which is going to be this string with a number in front of it. That's what we print here. Okay? How many people here want to see or care about what the code is inside of demo workers? Okay, enough that I will show you. Okay. Hang on. So that is in examples. Where's HTML5? Sprite HTML5. Here we go. Okay. So that's it. So we do this dot on message. Same thing. So right. So when we receive a message from the other thread, which is the other now is the browser. Right. So when we receive a message from the browser, that's when we're going to actually do our work. The message is going to come in as an event. It's going to have text. What is this text? Yay, or bottles of beer. Right? It's whatever text is being sent. So we're going to store that in T. Okay? Then what we'll do is we'll call this function, which will increment a counter, and then it will append, it will do that counter, which is a number, right? It's initialized to 0, it's a number, type number, plus T, which is a string. What happens when I put a plus between a string and a number? Concatenates. Remember, you look to your left, you look to your right. If either side is a string, it's a concatenation, right? So in this case, this is a string, so it concatenates this with this, so you get some number concatenated with bottles of beer. And you'll do post message. Post message is sort of a global function that's given to you, okay? And what this will do is it will send a message to the other thread, the browser, which will then have the on message where it will receive it, and it will set the inner text of the node, so you will see N bottles of beer. Yes? Just as an example, I just want to show you how you can send stuff. You can send anything. You can send an object, you can send numbers. Okay, I mean, yeah. I don't think this has a reference to any of that stuff. I think if you wanted a library here, you would have to explicitly load the library here. The reason why I'm saying this is because consider the following. Suppose you loaded jQuery, and this had access to that jQuery that's in the other thread. What if this then modified that object, the jQuery object, right? Say, removed functionality from it or whatever, or edited its prototype, okay? It now modified a state that is over there. That automatically breaks this assumption that the state of this is separate from the state of that. Do you see what I'm saying? So the problem with multi-thread programming is that it's shared state, right? That this can have big problems for this, right? So this can modify something that this is reading from, and this can do a lot of bad things that this cannot. The idea between messaging, even though we were doing multi-threading, by putting messages between them, we're saying these two are separate. They have their own memory, they have their own everything, okay? Keep them almost like processes. Imagine they're separate processes, okay? Keep them separate, but you can have inter-process communication using this messaging. It's actually not a separate, it's actually a separate thread, not a process, but imagine it like a process. If it's a separate process, you can't have shared libraries between processes, unless this process sends that library over, right? So Did that kind of answer your question? So if you wanted to use directives and so on, well, first of all, I'm trying to understand. I mean, okay, here's one thing. If you wanted to do some processing on an object that's attached to a dollar scope, that's one thing. What you would do is you would hash that object here. It would be a copy node. It would render it, and then it would post it back. You would capture it, add the new object back to dollar scope, and do dollar apply or dollar timeout. And that would, you see what I'm saying? So you can still use this to do some processing on an object, but it would be a separate thing that you would then get back and then add it to your dollar scope. Okay. Other questions? Cool. Okay. By the way, could you guys read the code? I'm sorry, I realized it's small. Is this okay? Keep going. Oh. Ah, this one, please. Each plus mята. You're saying this is faster than the other one?
Yeah.
Really? Why? Oh, heter kira. Chigidei. Can. Awesome. Okay, I'll do. No, this is, look, it's a great piece of advice. Let's search for it. Make sure that it's right. Not that I don't trust you. You know I trust you. But I always validate anything, right? So we'll no, but this is great. I mean, if that's the case. Oh, Crockford. Crockford, he doesn't like it not because of the performance. He doesn't like it because of the readability. He just doesn't like the way it looks, basically. Right. Okay, cool. So I'll leave it like that. How about that? Okay, so we know how to spawn web workers. Okay, guys, another thing. So closures are not cheap. What is a closure? A closure is basically a function, right? Every time you make a new function, that's adding overhead because each function has its own scope, right? Each function has data structures that can store local variables and local functions and local whatever, right? So every time you spawn one of these, it's actually overhead. Knowing this, you have to be careful about using iterators like for each. You guys know this? You can do array.for each, array.map, array.whatever. If you don't have to use it, if you can just use a regular for loop, use it. But if you feel like it's going to improve readability or it's going to make your code very unstable, okay, then use this kind of stuff. The reason for this is, first of all, any iterator that you have like this, even the native iterators, by the way, the one where you do array.forEach, it's still actually going to be a little bit slower than doing for, like writing a for loop. Number one. Number two, you're adding a function, which is already, it's a function call, and the function itself has scope. So you're adding all this extra levels of stuff for that kind of for each, and then putting in a function. So use it if you think it's going to massively improve the readability of your code, or if you think it's going to massively improve the stability of your code. But don't just use it instead of a for loop. I could use a for loop, but I'll write a for each. No. If for loop makes sense, use a for loop, or a while loop, or whatever. That is actually going to be faster and cheaper as far as memory is concerned. Yeah. It's all, because all of those things, if you think about it, it's iterating over some set and calling a function, right? Map anele. Okay, this is an example of where a for would actually be more complicated than a map, for example. In which case, yeah. But, okay, a lot of people, for example, will use a map where they don't need a map. They will use a map instead of a for each, or they will use a for each instead of a... So their map will return the original object. I've seen it. It's not funny. I've actually seen it. So don't do that, right? Use the right tool for the right job, I guess is really what it is. Translate that. Map beats Lavachka. But if you're using map to do what a for each will do, and you're using a for each what a regular for loop would do, then animasta, then it's stupid. Good? Alright. Remember, okay, we talked about this before, but I'll just remind you that JavaScript has automatic garbage collection. A garbage collector, if you remember, is the one thing that can and will interrupt you. Right? No other algorithm will interrupt your thread, right? Except for the garbage collector, which at any huh? Yeah, but alert, it's part of your algorithm, right? You're writing alert, so you're interrupting yourself. It's not an interrupt, it's part of your algorithm. You're right. So what he's saying is when you do an alert and you get that dialog, your thread is frozen so that the next line is not executed. True, but you did it. You called alert, right? That's your algorithm. This is all I'm saying. What happens with garbage collector, it comes and interrupts you without you even wanting it to. Okay? So that's the problem. Ooh, it's 11. Ooh, we got to get to the most important part. Okay, so very quickly rendering. So by this I mean kind of reflow and repaint. So if you guys remember, I'll just remind you what it is. We have reflow and we have repaint. So the difference is, moment. Yeah, repaint. I don't have a definition for repaint. I'll just tell you. Okay, here we go. So this is the important part. So what reflow is, it's the part that will look at the elements and the CSS and any additional information that it has, and try to figure out the geometry of where things should be. What the size should be, and where things should be relative to each other. Okay? So figuring out where to put things in the actual view. That is flow. Reflow means doing it again. Okay? So the idea behind this is that one of the things that made browsers scriptable was this notion of not only, it used to just run flow once, compute where things are going to be, and then pass it to the rendering engine, which would then paint it to the screen, and then you're done. Now what you have is that first algorithm that reflows and then results in the paint can execute again. So you can, in your script, modify the HTML or the DOM, and that will cause this to rerun and repaint. You modify it, rerun, repaint. And that's how all the applications work in the browser. Very simple. Okay? So that's what I mean. So by reflow, I mean recomputing where things are going to be and the geometry. Repaint is the actual process of spraying it onto the screen, the pixels. Okay, so when does reflow actually run? Well, it always runs initially when the page loads. I think that's kind of a given. When you resize the browser window, you're now changing the size of the real estate, right? The size that is available to you to render. When you do that, when you shift in size, that changes where things should be, possibly. And so it has to recompute. So whenever you change the size of the window, it does a reflow. Whenever you add an additional node, that may have to shift another node down, which may have to shift another node down, which may have to shift the next node to the next line, right? So adding and removing elements to and from the DOM is expensive. Okay, whenever you apply style, so you change the width of something, or you change the height of something, right? That is obviously going to result in a reflow, because you're now changing the structure of where things are. This is the one that many people don't know about. When you read layout information, that causes a reflow. Okay? Yeah. Okay, so here's why. Okay. So browsers are very smart. Okay? And what they will do is, if you're actually, in reality, if you're actually changing, applying layout, so you're changing the CSS left, you're changing the CSS width, you're changing all these attributes, it won't actually reflow each time. It will try to batch it. Okay? Internally, it will try to say, oh, you just did this, let's just wait. Is he going to, oh, you changed something? No. Okay, now wait. Okay? It's very smart about when it reflows. But here's the thing. When you read, in order to give you the result, in order to give you the answer, it has to recompute in order to know what the answer is to give you. You guys see it? In order to recompute, it has to actually run the reflow. So by reading, you're actually forcing it to run. It can no longer batch. Let's see if I have an example here. Oh, I don't have an example here. I don't, really? I'm very sorry. Next time I'll have an example. Okay, I'll make up an example. Here we go. Suppose you're writing, oh, I know. suppose you're writing an animation, okay? So you're saying, for each loop you're going to update the left and the top, okay? And you're going to shift it somehow. Now what you do is, in the first line, you read the left, you increment it by some value, and then you write it back. But then what you do is you read left from the DOM node again to add some value to add to the top. I realize this makes no sense, but just bear with me. The fact that you read left back means that left actually has to get applied in order for it to then give you the result. You guys see that? Right? So whereas if you didn't do that, if you just applied the left and applied the right, it might have batched those two and did one reflow. But because you did an explicit read, it now ran it in order to give you the right answer, and then it's the next line. You see it? Exactly, instead of one. Yeah. Okay. Okay, so put style sheets at the top. We discussed this, probably in head. If head doesn't exist, just put it at the top. Put scripts at the bottom. Again, this is so that your browser doesn't freeze, and then script runs below. We know this. Put as few DOM elements as you can. This is actually important. I've seen a lot of people who always add additional divs everywhere. Don't add a div if you don't need a div. Seriously. Okay? I've seen HTML where there's just like a div. I mean, there's HTML and then there's just divs wrapping things. And there's no selectors that modify it. It's not used for layout. There's just extra stuff. All of that will reduce your performance. Okay? Keep your elements to a minimum. Minimize reflow. Oh, wait. Okay, so here maybe I will have some things. Okay. Wait, you guys know this stuff. You know this. Get on with attack. You know this. One sec. You know this. Offset top. Avoid force. Okay, I want to find that example that shows you that whole. I think it might be this one. Wait a minute. Remove child. Clone node. Append child. Oh no, this is just bad because I keep adding elements to it. HTML collection, alive, infinite loop. Use smart CSS selectors, browser read selector right to left, and hang out to specify width and height of all images. Okay, so here's a good one. So if you're loading, remember how I told you that actually the way this whole notion of reflow came around is that the browser was reading the HTML, would find an image, not know how big it is, put a placeholder, and then keep going. And then when the image came, it would put it in, read the size, and then reflow. Remember this? Okay, well, if you specify the size of the image, either in your CSS or as an attribute, it won't reflow. It will simply repaint the image that's there. Okay? So specify sizes of images as you can. Okay, good, we're done. So let's take a quick picture, take a break, and then come right back here for the part that I think is actually the most important part. Clean code. Hang on. Vad vill han säga? All right, this is, oh man. Could I ask you guys, like, est-ce que t'en vas à Mickey Jeskongak? Maki boşan uzun hadi All right, perfect, good. This is the 12th and final set. Okay, let's do 12. Ducho, 1, 2, 3, 12! All right, thank you so much. All right, quick break, guys. Not the usual 15, 20 minute, just go do whatever you need to do, come right back.
Prozran լոքչեր, բայց թաթիլ տան շեփեջի։ Նշանակում է շուտ չեք։ Այս փեջը լոքչեր։ Ադին մշակել։
Haydi oynak laklar.
Controller is directive image. The controller directive directive is controller. Directive controlling
Your team is
Բայց եթե անպայման directly like direct controller register on implementation. I think can also use for եթե հնարավոր է, շատավելակների հետ ֆունկցիան հենց ստեղծեք, directive means object at factory. The controller is an object at factory. You just make our but concrete directive controller Ինքն է կարող subscribe կրել։ Ուրեմն ամեն նկարի չափը գիտի, ինքը այս եկեք գիտի չափը, ամեն ուրեմն կորնները հակած աղբասից Հաստատ երկրորդ բաց չկա։ Նույն spray, նույն CSS բայց ինչ-որ մի ձևով հանգած position-ը հենց HTML կողմի վրա է ստայլի։ Ասի անունը because I recomputed let's start from a classroom առաջին բանն է, բայց այդ performance-ի առումով լավ չի մտնում, բայց ճիշտ է միած CSS։ Բոլոր Esther, die Luca hat da.
But it's
Կոմպով տեստես արա արդեն հա։
Okay, Rose. Schauen wir like a All right, gather around, gather around. So this is a talk that I gave during bar camp, this past bar camp, but hopefully since we have a bit more time, I hope to get into a little bit more detail, although we don't have a lot more time. Yes, shot, you've got your gun. That's okay. Alright, so clean code. So first of all, this talk is entitled Principles of Clean Code, and let's begin. So what do I mean by clean code? Actually, before I begin, very quickly, this is VMware, right? This is VMware stuff? There are things here about VMware. They're looking for talented engineers. If you guys are looking for work or whatever, pick up the flyer, check it out, great stuff. Okay. All right, so clean code. First of all, what do I mean by clean code? What I mean by clean code is code that is simple to understand. That's it. It's code that is written simply and clearly, and any engineer who understands the language, understands the technology, can read what you wrote and clearly understand exactly what you're doing. Okay? That's it. That's what I mean by clean code. Okay, so why do we need clean code? Why is this so important? Why have I been talking about this all this time saying, you know, if there's one thing I hope you guys take away from this, it's this understanding that clean code is important. Well, there are a few reasons. So first of all, most of you are working with teams, right? So whenever you're writing code, you often have other people that have to go through your code and try to understand what you've done. Whether they're debugging and they happen to be stepping into your code, right? Whether they're actually trying to maintain your code, whether they're trying to add features to your code, other people are always reading your code and you're reading other people's code. So that's one reason. It's basically to do other engineers a favor so that they're not struggling trying to understand what you've done. Fair enough. The second reason is that writing simpler code actually reduces bugs. So here's the thing. When you write less code and clean code, and code that is very obvious to understand, you actually introduce fewer bugs than if you write really weird, complicated code. Okay? And hopefully you'll see how that is moving forward. But I think you guys understand. The more complex the code looks, the more bugs or problems it can have. I think this should almost be obvious to you. The third reason, and I think the most important reason why you guys should write clean code, is to do you a favor, yourself, you as engineers. The reason for this is because you spend much more time reading code than you do writing code. Okay? This should be obvious to you, but in case it's not, the next time you're at work or somewhere where there are a lot of people who are programming, watch what they're doing closely. Okay? But watch them not while they're, writing emails or instant messaging or doing Facebook stuff, but we're actually coding, okay? See what they're doing. Are they just, or are they kind of staring at the screen trying to understand what they've done? It's usually the latter. It's usually, you're just reading code trying to understand what's going on. Way more than actually adding code. Maybe at the very beginning, but once you actually build up a real code base, you're just reading that code. You're debugging that code, you're trying to understand what all the various pieces do. Right? So it makes sense that for you as engineers, if you're going to be reading code that you're writing, you might as well do yourself a favor and write readable code. Og helt standardwerk. So what can we do to write clean code? So one thing to do, one obvious thing to do, is to write less code. Okay? So less code, literally the less code you have, the simpler your code is to read usually. Right? The less lines of stuff you have to scan, the fewer variables you have to remember, the easier it is to take that algorithm, put it into your head, and begin to think about it. So the smaller that is, the easier it is to comprehend. Okay, so how can I write less code? Well, one way to do it is to use libraries and frameworks. Right? That's effectively what libraries and frameworks are there for. It's to make your lives as engineers easier. Because if you think about it, if you write your own code from scratch, right, you have to, first of all, write all that code, then you have to document that code, then you have to unit test that code, and then you have to actually use the code, find all the mistakes that you've made or the corner cases that you forgot to handle, go back, fix those mistakes, add those cases to your unit testing framework, possibly document any additional code you have written, redeploy, and go again. That is a lot of work. Okay? So one way to minimize all of that work, all of that effort, is to use libraries and frameworks. We talked about a number of these here. We talked about jQuery, we talked about Angular, Backbone. Just think about Angular for a second. Think of all the things that Angular gives you. Right? This notion of routing, right? Angular gives you this ability to create directives. It gives you all kinds of things right off the bat, right? All these utilities. You can make AJAX calls by using the $HTTP thingy. I don't know what it's called, the variable thing that gets passed in and gets injected. It gives you all these things right off the bat where you don't have to worry about it. You don't have to write it yourself. Imagine if you weren't using Angular and you had to write all of that code yourself. Think how much code you would end up with. Think of how much bulk that would be. Right? So use and leverage libraries and frameworks to have less code. This will make your code easier to read and easier to maintain. I jumped ahead a bit, but one warning I should give you is that these are just my opinions. I didn't learn about this in school. Okay? When I went to college, no one sat me down and said, Rouben says, you have to write clean code, but no one actually sort of did this. So I kind of picked this up as I went. And this, I think, is the single most important lesson that I've learned as an engineer, is to keep your code simple. Okay? Simple code is easier to read than complex code. So the second part is to write code that looks familiar. So here's what I mean by this. If in one function you wrote code where you're using the dollar variable, okay? And the dollar variable, at least in JavaScript, is usually jQuery, right? We kind of studied this. If you have another function where you have the dollar variable, don't have it be something else. The reason for this is it's weird, right? People read the dollar, they understand the dollar is jQuery. When they shift to another function, they see dollar, they shouldn't realize that dollar actually is something completely different from something here. Every time you force someone to do this shift, every time you force someone to do this switch of understanding this versus that, you're adding work. Minimize the work. Minimize the work that it takes to understand what you've done. Okay? Again, because you are doing yourself a favor. I've met lots of engineers that have written code where then they were asked to go back and change something in that code and said, oh come on, because they know what they did. They know the crap that they made, that then they have to try to, and understanding the garbage that they spat out is as difficult for them as anybody else. Right? Going back to your code should not be a disaster. Okay? If it is, rewrite your code. Okay? By the way, that's another theme that I hope to push, is don't be afraid to rewrite. If you do a crappy job, if you do a bad job, do it again. Sorry about that. Do it again. Okay? Put it aside, throw it away. If it's garbage, leave it as garbage. Do it again. Okay? Now you might say, wait, but time. We have a deadline, we have all these things. I don't have time to go back and fix this garbage that I made. I'll tell you this, you're actually adding more time by leaving it as garbage than you would be by going back and fixing it in the long run. Because every time you go back, it's going to take you that much longer to understand it, that much longer to debug through it. All the errors that your code that is garbage is going to introduce, and all the debugging that you'll have to do in the future, all of that is time. That is time. Rewriting this is not time. All that other effort, that's time. And that is serious time in money, in resources, and in you. Right? So if you see that it's garbage, fix it. Don't keep going. Okay, so very quickly. So the other thing, so what do I mean by code that looks familiar? You guys, at this point, most of you know your data structures, right? So you understand, like a stack, or first in, first out, and so on. If you're going to implement a stack in your code, use push and pop. The reason for this, and call it a stack. Call it an undo stack, call it whatever stack. The reason for this is because immediately when someone reads your code, they will look at it and go, oh, it's a stack. And without even reading too much into it, they'll know that it has a push and pop. And they'll know how push and pop works. Basically, think of it this way. People come to your code knowing other things. Okay? Obvious, right? What you want to do is you want to have your code fit in with the things that they know. As much as possible. Don't go counter to what they know. An example of this is, suppose you called something a stack, but the stack did not have push and pop, which is what stack should have, but instead had like add and remove. Okay? That is counter to what we know, right? We know that stack has push and pop. If your stack has add and remove, that is, they'll figure it out. They'll read the code and go, oh, it doesn't have a push. It actually has an add and has a, okay, they'll understand it. But they shouldn't have to go through this additional work, this additional exercise of understanding this. They should be able to bring in the knowledge that they know, the assumptions that they know, to better understand what you've done. The moment you go counter to that, you have a problem. Here's an obvious example. We all speak English a little bit, right? Suppose I was talking to you and I was saying the word yes. But instead of yes, yes meaning yes, like yes, hello, yeah, yes, ayo, right, yes, I meant yes to be car. Right, exactly. So it would be weird. The conversation would be weird. And the reason why it would be weird, it wouldn't be weird for me because I know what yes is. And as long as you make the same assumption, the conversation would go just fine. The problem is when you first come in and you start talking to me, you assume yes to mean yes. Whereas if I assume yes to be car, suddenly there's a break in dialogue. You eventually figure it out by doing some work, trying to interpret what I'm saying. But eventually you figure it out. This is what I'm telling you to avoid in your code. If someone is coming in with a set of assumptions, have code that fits in with those assumptions. Write code that fits in with standards. Okay? Write code that fits in with what people usually do. Don't go off and do something else. Don't name your jQuery variable bolos. It will work. We know it will work. But it makes it difficult to read because now someone has to know what is bolos. Oh, it's jQuery. Whereas $, they know it's jQuery and they're done. And make sure that $, is jQuery so that if I assume it's jQuery and then realize, oh, it's actually not jQuery, it's car, not yes. It's that extra step that I shouldn't have to take. Okay? All right. So that's that. Okay, stick to the language convention. So and this is just one example of why it's important to stick to convention. So in other languages like C and Java, where you put your curly braces is kind of arbitrary. Okay, some people really like to put them at the top, some people really like to put them in the next line. In JavaScript, the convention is to always put them in the same place. And here's why. Do you guys remember what this function will return if I call it? I think each could add us. Undefined. Okay? Just like us. Exactly. It will come here and it will put in a semicolon and it will return undefined. To avoid this problem, you need to stick to convention. The convention is that the curlies always go to the next line. Okay? And if you stuck to this convention, this bug would never happen. So this is one example where sticking to convention, sticking to these rules, will actually save you time as far as the number of errors that you make. Okay? Again, sticking to convention also helps with readability. We like reading beautiful code. Okay? If we read code where one of the curlies is here and the other one is here, and it's weird. You can, yeah, you read it, but it's, see, when you're reading, I mean, code is grammar, right? It's like reading sentences. It's grammar. And if the grammar kind of has a nice logical flow to it, it's clear and it's nice and it reads like, like Dostoevsky, it's beautiful, right, as you read through it. But if you just have a bunch of statements that each one is just, it's hard to read, it's disgusting almost. Okay? So stay away from that. Literally try to make your code beautiful, if you can. I'm telling you, it actually matters. Okay, avoid deep nesting. So, oftentimes what I'll do is instead of doing if foo, if bar, and then the actual stuff that matters, okay, what I will typically do is I will do something like this. I will check the foo and bar, and then if either of them are wrong, if I'm throwing exceptions, I'll throw exceptions. If there's an error thing I need to return, like error null or -1, I'll do it here. And then the actual body, the content of the code goes below. This is simpler to read because right off the bat, you don't have to go into this nested deep thing where you're like, wait, where did this end? And then you have to line up the curly braces. And if it's too long, you have to scroll up and see, oh, this lines with that. Forget that. Try to keep your code as much in the same column as you can. Don't do too much nesting. Okay? It just makes it harder to read. Okay, keep variable names short and descriptive, okay? So you don't want your variable names to be too long. Because again, you don't want to write these long sentences in your code. It just makes it difficult to read. At the same time, though, don't call them a. Right? Call them something that makes sense. Call them something that when the user reads that variable, they understand what the variable is and what the behavior should be. Don't do too much in a single line. So I brought this example up, I think, once in the past, where I was working with a very talented engineer, a very smart guy, and while reading through his code, again, debugging through his code, which we often do, right? While debugging through his code, I found a function that had the entire body of the function in one line. And it had regular expressions in there, it had like, crazy stuff, right? And it was not obvious what he was doing, right? To try to understand what he was doing on one line was not easy. But once I understood it, I understood that everything that he did could have easily been represented in a few lines of code. And just by looking at the few lines of code, you would understand exactly what he did. So by showing off and putting everything in one line, he actually made his code more difficult to read, more difficult to debug, more difficult to maintain, right? Don't do this kind of thing. Write your code cleanly. And here's the thing. So you know how I keep telling you guys to write less code? Write less code when it's more readable. Sometimes, writing a little bit more code makes code more readable. There are cases. An example of this is this example that kind of keeps coming up in JavaScript, which is comparing to see if a variable has null or undefined. Some of you may know that you can just do double equal null, and that will return truthy if it's null, and it will return truthy if it's undefined. The problem is that some people know this, but most people don't. And even those who do are not sure if it will work the same way if it's nan or if it's any of the other falsy values. And this introduces a little bit of ambiguity. To make your code simpler to understand, do triple equals null or triple equals undefined. There is no question about that behavior. That behavior is absolutely clear. Right? You look at it, you know exactly what it does. That is actually better than the previous, even though the previous has less code. Make sense? Okay, so this is an important one. So design systems as a series of modules. So think of it this way. Don't build complex systems. Right? No system should be built as this big, complicated thing. Think of an operating system. So an operating system is big. It's got lots of these things, right? But an operating system is not one big thing. It's actually lots of little things that, when combined together, build this big, complicated thing. Okay? So think of it this way. Don't build complicated systems. Instead, build small, simple systems that, when combined together, produce complexity. Okay? Now, keep in mind, again, I'm not suggesting that you should build stupid systems or systems that don't do interesting things. I'm saying do all that, but still do it in a way where the individual pieces are easy to debug, easy to understand, easy to test, easy to maintain. Okay? So how do you do this? Well, you break your code up into pieces. You break your code up into modules, into objects, and functions within those objects. This is what we generally refer to as object-oriented design. Right? So breaking your code up into pieces, into objects, that then come together and build something really cool. So, and we studied object-oriented design, right? JavaScript is as object-oriented as it gets. Everything is an object almost. Right? A function is an object in JavaScript. That's amazing. So yeah, so always, whenever you're designing a system, or you're thinking of, well, how do I build this application? Don't think of it as an application. Think of it as pieces that come together to produce the application. Okay, maintain high cohesion within your modules. This is a complicated way of saying something very simple. Whenever you create a module, the things within that module should be similar. Okay? So, an example. Suppose you're creating an object called person. Okay? So you have things in there like name and phone number and things having to do with a person. Don't throw an airport inside of that. Okay? Because airport has nothing to do with anything else, right? So you want to maintain a tight cohesion. The things have inside that module should have a lot to do with each other. Anything else should be put into a separate module. Okay? That's what this means. Okay. This is probably one of the most important things that I hope you take away from this part, which is to write loosely coupled code. So what do I mean by this? So we talked about breaking our code up into pieces, right? Into sort of modules, into separate groups of stuff, right? So imagine this is a group of stuff, and this is a group of stuff. So this is a module, and this is a module. Modules need to communicate with each other, right? Okay, so that channel of communication, okay, this window through which they communicate, excuse me, is generally referred to as the API. It's the application interface that we're using to communicate or to interface between modules. Okay? There are a few things here. First, you want to make sure to keep that window as small as possible. That's number one. The second thing is you want to make sure that all the logic that's in here is abstracted away, closed in a box from anything outside of it. In other words, parts of the system that are interacting with this module should not know anything about the details inside of this box. All they care about is this window through which they can communicate. There are lots of advantages to this. One of them, first of all, is that you can change stuff here without changing anything else out there. Right? If you have, as long as you stick to this API, as long as you still, this is a promise that you're making to the rest of the system, where you're saying, I will support these functions, these methods, these behavior, as long as you make the appropriate calls. How I do it is entirely my business. And so things can be changed here, the implementation can be changed here completely. As long as it maintains this API, no problem. You might rip this out, bring in an off-the-shelf module. Again, as long as it supports the same API, it will continue to work. And a simple example of this. You go to, I'll use the same example I used last time. You go to a pizza place, and you order a pizza. Right? So you are talking to the person at the desk, and you say, I'd like a pizza with cheese and mushrooms and whatever. And they say, okay, no problem. You give them the money, you wait, and then at some point you get your pizza. Right? The complexity of how a pizza is made is entirely abstracted away from you. It's behind the counter, right? It's in the kitchen. You don't even see it. Right? What dough they make, how long they turn it, the oven that they use, how long it's in the oven, what vegetables they use, how the vegetables got there, the supply chain that was used to get all that stuff into the store. All of this information is abstracted away from you. It's not your business. It's not your concern. This kind of thing is also often referred to as separation of concerns. Okay? So what concerns me, what I care about, and what concerns the people who work at the pizza place, what they care about, is separate. All we care about is this window through which I can interact with someone to say what I want, perform the transaction, give them the money, and get my pizza. Okay? So this is what I mean by that. So when you design your modules, keep them as separate as possible. And this module should know absolutely nothing about this module. Only the API, the window through which it will communicate to. The second thing that I mentioned to you is you should keep this window small. Why did I say that? The reason for this is this window is a promise. The more promises you make, the more promises you have to keep. I think that's obvious, right? Okay, again, I'll say this again. The more promises you make, the more promises you have to keep. The more promises you have to keep, the more responsibility you have on your shoulders, right? So think about it. If you promise everything, if you promise the world, 500 functions, right? And with documentation, that's that much function that you have to maintain if you ever decide to change something here. If you ever decide to swap this module out and bring something else, that's that much that you have to maintain. So just as far as the maintenance of this module, maintaining a bigger API is complicated. Just in that. It's also complicated from the user perspective. Have you guys ever tried to use a module that had like 1 billion functions in it? I'm sure some of you have, especially like C# and Java people. I know you have. It's hard. The reason why it's hard is there's so much. It's hard to understand, like, which function do I use out of these, 500 billion functions. Having a smaller API means having a handle on, okay, this function does this, this, and this, and it does it well. If I want to do something else, I call another function which does this, this, and this, and it does that well. Always think of this way. Write a module that is small, does a few things, but does those things very well. Okay? Think of it that way. It's better to have something small that behaves well, that is well tested and well documented, than to have a Goliath that tries to do everything but does a crappy job. Okay? And if you do have to, again, build something big, instead of having one module, have 10. In JavaScript, by the way, that's a huge benefit. jQuery, for those of you who may not know this, has actually moved to this model. jQuery used to be jQuery. There was jQuery, and that's it. Now, jQuery is actually broken up into pieces. And you can actually pick which of those pieces you want to use. The benefit of that is, first of all, you end up downloading that smaller code base from the server, right? Because you're only downloading the piece that you want, not the entire thing to use one function. Number one. Number two, because once you get the smaller piece, all your code is interacting with the smaller API. So when you're reading the code, you don't keep bumping into different functions. It's one set of functions that you understand, you learn, you know how they work, and now the whole code is using those few functions. And that is much easier to understand than trying to call anything. You guys see this? jQuery. Es verčin երկու point dissemination, verčin era, our gnak, jQuery UI did this a long time ago. I think with jQuery, I'm pretty sure they did this. Yeah, you can go to a build, and you can pick which one part of jQuery you want. And you can actually pick and choose which one. It's pretty cool. Questions about, this is one of the most important parts of, not just today, but of this entire, I don't know how long, 12 days that we've been together. Are there questions here? Okay. By the way, just very quickly, I know there's probably a lot of Java programmers out there. Think of it this way. Think of the interface, literally interface that we call in Java, as being the API, being this window, and this is the implementation of that interface. Maybe that makes more sense to some of you. Okay. This is also really, really important. So we talked about APIs, right? Those modules are going to have functions that we can call to do something on our behalf. Okay. Those functions should take as arguments as little as possible. Okay? Don't ask for more than what you need. Be minimalistic about what you require the users of your stuff to do. So in this case, this is a very basic example. I have a manager. And then in the function, I do manager.info.getID. So I get an ID from info that is attached to the manager, and then I do something with that ID. This is asking for way more than what it needs. All this needs is an ID. It doesn't need a manager. It doesn't need the info object. All it needs is an ID. Why did it ask for a manager? Also, imagine, first of all, when using it, you have to now instantiate a manager if you don't already have one. Make sure the manager has info attached to it, attach the ID to it, and then call this function. You have to do all of that when you test it as well. In this case, I've rewritten this function to mean what exactly it should be, which is it takes an ID and does some work. This and this does the same thing, but this requires less from the user than that. You guys see that? Same thing goes with writing REST APIs on the server. I've had lots of arguments with engineers who are building applications on the server where I said, I want to send you this ID and you do the rest. They say, no, I want you to send me the ID, the name of the user, and their email address. The response is, if you have the ID of the user, you can look up all of that information from the database. Why do you need me? Why are you asking for all this extra information that you don't need? Right? It's like, don't ask for more. If you know how to get to it, don't ask me to give it to you. Okay? Ask for as little from your users as you can. By the way, this same concept also applies to building user interfaces. Don't ask people to click more than they have to. Don't ask people to type more than they have to. People should do as little as possible and still use your application. Always make the lives of the people who use your application easier. If you can guess what they want to do next and just do it, that's always better than having them explicitly tell you what they want. The more work they do, the work. There's actually a book on this called Don't Make Me Click. And it's a user experience design book, which says basically exactly this. Don't force users to take more steps than they have to. And to me, users of my APIs are just users. A programmer to me is a user. programmer wants to use my module, wants to use the functions that I wrote, I should make it as easy and as pleasant to use my functions as possible. Why? First of all, I love my fellow programmers, but also I'm one of the users. I'm using my own code. So I want to make it easy for me. I don't want to have to fall into a situation like this, where later in my code I want to call something to get something by ID and go, oh, I have to instantiate a manager, I have to get info, I have to attach the ID to the info, and then I have to call this function just to get the same thing that I could just do like this. You get that? Ask for as little as possible. Make your stuff as easy to use as possible. Simplicity is key. This is what I keep saying. This is the main point. Keep things simple. Do everything you can to have your system be simple. Software systems are complicated as they are. Don't make them more complicated. Make them as simple as possible. Alright, so don't be careful about global variables. Okay, a few sort of specifics about why global variables are evil. So first of all, they have no locality. What I mean by this is, imagine you're debugging a function, and that function has a variable inside, right? You know the scope of that function is this. And you know that this code here is the only thing that will ever modify that variable. So you can kind of assert, based on reading the code, all the different things that can happen to that function, and all the results that can happen from modifying that function, because it's all encapsulated in one block. The moment you put your variable in a global scope, you've lost these assumptions. Because that variable can be anything. Literally anything. Any module that you load can reference that and modify it. Right? That's a problem. And that makes things very difficult to debug. It makes your code very difficult to understand. Right? So be very careful about putting things in the global scope. The one time where I might be okay with it, and even this you should minimize, is if you're doing something like, public static, public final static, whatever. In other words, you make a static variable that will not change. You make it final. Then maybe. But even then, I would suggest that you don't do that. Because again, reading code makes it difficult. Because suddenly you're referencing a variable where the value is not created in the part that you're reading. You now have to jump somewhere else to understand just what that value is. Okay? Minimize global variables. Here's another one. It has no access control. Again, this refers to, obviously, actually not just the variables you can edit, but also the variables you can read from. No access control means anyone can read it, right? It's global. And if it's not final, if it's not constant, anyone can modify it. That is very dangerous. It's very difficult to, because think about it. We're doing everything we can to make reading code simpler. The moment you start reading code that the entire universe can modify and read and do all kinds of things with, it's more difficult to reason about your algorithm than it is to know, okay, this is the value, this is all it's going to be in this block, and if I ever want to change the variable, I can do it without having a repercussion over here. If I edit the variable here, I will not change something here. With a global, if I change it, I can change something anywhere. You guys get that? Okay, global variables lead to namespace pollution. In JavaScript, this is a fundamental problem, but it's also a problem in other languages. So in JavaScript, if I create a function, in this function I declare a variable, I, and I set one in it. But I forget to put in var. What happens? It becomes global. Okay, here's another one. I use I, but I forgot to declare I in the function. If I happens to be global, I'm now accidentally reading and possibly editing a global variable, which is having repercussions somewhere else in my system. You guys see this? Avoid global variables as much as you can. By the way, in JavaScript, one way to do this when you're debugging, read the window object. In the console, just type window, and it will give you that object, and you can collapse it out and see every attribute in window. First of all, you should know many of the attributes that are there, but look for attributes like I. It's a common one. I see it all the time. The first thing I do whenever people are like, oh, my code doesn't work, I open window and I look for I. It works, I'm telling you. Why? Because usually someone in some for loop, for example, forgot to put var, declared an I globally, and is now using I everywhere, possibly if there's a window set timeout, or if there's any race condition, or if he's not initializing it, is now causing all kinds of errors in the logic. So look at window and make sure, monitor window and make sure you don't add any additional garbage to it. Die. We know what die is now, right? Can someone tell me what die is? Yeah, duplication is evil. Sorry, you raised it. Yeah, duplication is evil, that's right. So avoid copy paste. So whenever you have duplicates in your code, the fundamental well, first of all, you're adding bulk, right? You're making your code base that much bigger that it shouldn't be. If it's doing the same thing, wrap it up in a function, call it, no problem. The second fundamental problem is, if you fix a bug here, you still have a bug. Right? So be very careful about duplicating your code. Avoid spaghetti code. So this is just basically saying organize your code properly. Don't end up in a situation where your logic is so interleaved that it's difficult to understand. Now the question that people often ask is, well, for user interfaces, how do you avoid this? So before I move on to MVC, which we've studied, remember, suppose you don't use MVC. If you just use jQuery, again, remember this problem. It's a very simple one. I have a text box here that's editing name, and I have a label here that's rendering name. I want to keep them in sync. I can use jQuery to listen to change events here, and update the code over here with a callback handler, right? Okay. Now suppose I also want to edit name here, and I have another label here. Now what I have to do is I have to add additional code for this one to update this, this, and this, update this code to update this, this, and this. Okay, so now this has a reference to that, this, and this has a reference to this, this, and that, right? Okay, hang on. Now I add more stuff, and I have to reference, you guys see what you end up with, right? That is what I mean by spaghetti. Okay? The way to avoid that, or one clean way to avoid this, is to use this notion of MVC, Model View Controller, which we've discussed. Woo! All right, so we know what MVC is, so we'll okay, CRUD. So when making REST APIs, one thing to know about is CRUD. Who knows what CRUD stands for?
Create, read,
Sorry, so get that one. Create, read, update, delete. That's right, yeah. Okay, so the idea is that your server should be effectively a store for maintaining objects. Okay? That's what a server is. It's a place where you put objects. You put people, each person is an object. You put companies, each company is an object. You put, I don't know, likes. You put comments. All of these things are objects, which get stored on the database somehow. They may get stored in tables, relational databases. They may get stored as objects, like MongoDB. How they get stored is entirely the business of the server-side code. But the notion is, I have an object and I need to store it. I also have an object that I need to get. I have an object that I need to update. Update. I need to create another object. I need to read an object. I need to delete an existing object. So the server, the traditional way, or one way that I really like to set up my APIs, is as effectively a service to deal with objects. To create, read, update, and delete objects. This is a very clean way to design your APIs, and it will very much minimize your code base. Very quickly, let me say how. So imagine building an application where you have a separate API call for every different kind of operation you can have. You end up with a massive API, right? Which suffers from the problem of, if you promise too much, you have to now fulfill all of those promises. Promise less, you have less responsibility, right? Okay, so instead of having different operations, instead just have create, read, update, and delete, and have the client decide which objects it needs, how it wants to put them together, and how it wants to render them on the screen. Also, if you think of data as just objects, using things like Angular is easy. Because what happens? You call read, right? So you get an object, you attach that object to your $scope, and voila, your UI is now rendered. It's that simple. And then if you want to update it, you call the update function, which will then write the changes that you made and update the database. That's it. Very simple. Okay, be very careful about this. Always page your data. Whenever you're getting lists back, always page. Always. Never assume that, well, the list is never going to be that big. It's always eventually going to be that big, guys, I promise you. There's always a case where you can go, oops, and so be very careful. Whenever you're running queries, always limit your queries. Never just say, give me everything. Always put a pager, always. Unless you're getting one thing, that's different. That's not a list. Write specs for your code. This is another way of saying write unit tests for your code. So, as you build out your system, right? Your system, even though the individual pieces are simple, as you start putting together, it becomes more and more complicated. Right? So if you have a complicated system, how do you know if you change something, if you've broken something somewhere else? I see this time and time again where people build out these really cool, interesting systems, and then they make a change somewhere, they add a feature, and then they end up introducing bugs somewhere completely different without even knowing. And they go, oops, okay, sorry, I'll patch that tomorrow. If you have unit tests, you know this. Because that's what one of the biggest things that I think unit tests provide you is this, is confidence. Knowing that even though you changed something, you didn't break the system. Having that confidence is awesome. Being scared of committing your code because you think that maybe, what if this variable broke that? You want to get rid of that fear. And the way to get rid of that fear is through automated testing. Comment all public APIs. I think that's easy. As people read through and want to use your functions, they might want to read and understand what they need to do. Not how it works. Nobody cares about how it works except you. They want to know how to use it. That's what I mean. Okay, comment that. Commenting the code is the second part, which is that's where you're commenting what you're doing inside. Now here's the thing. A comment should explain why a piece of code is like what it is. It shouldn't explain what it does. If you're trying to write comments to explain what you did in your code, you wrote crappy code. Do it again. Okay? Your code should be obvious. When you read it, it should read almost like comments, okay? Like sentences. If you wrote code that is so complicated that you think you need to comment about it so that the next poor person that has to read that code, not understand it, or at least have a comment, throw it away. Do it again. Okay? Refactor, clean it up, get it right. Okay. I know. So just a quick thing on this. So this is sort of my philosophy, but so why do I put this up? So the best way to learn how to write clean code is to write a lot of code. There's really no substitution. I can stand here and tell you all kinds of theory, all kinds of concepts, show you how other people did it. It's not going to help. It'll help, but you won't get good at it until you just sit down, spend the hours, and just code. Make the mistakes, force yourself to read the garbage that you wrote, and promise yourself you won't do it again. That's the best way. I know you guys have to go. I'm almost done. Okay, I think this is the last. Yeah, this is the last one. So last one, and then everyone goes home. So I took these three from Unix philosophy, which is sort of this big thing of what people in Unix should be following, right? These sort of core concepts of Unix. And I like these three very much. So first one is to iterate quickly. So I found that too many people will spend a lot of time talking about things, but not actually doing it. Okay? This is, I realize it's fundamental. People will spend a lot of time over-designing a system without even writing a single line of code. Guys, you will learn more from, you will learn more from writing code, from writing a prototype, from doing something, from actually trying out and getting your hands dirty than you ever will by just drawing things on the board. I'm not suggesting that you shouldn't go through an exercise of brainstorming. I'm not suggesting that you shouldn't sketch a few things out. But don't just sit there and do this all day. Actually code. Because I'm telling you, as you code, you will end up learning things that you never even thought about when you were just drawing things on the board. Okay? So iterate quickly. The other thing is if you write clean code, that means you can change your code easily without fear of breaking things, because remember, we have unit tests which validate the changes, right? So the code is easy to read, we can modify it quickly, and we know we haven't broken anything because we have tests that will make sure that doesn't happen. As long as you have those two things, you can iterate over your code very quickly. You can build an initial prototype, and then iterate over it and build it out and make it better and better and better. So iterate quickly. Shut up and code. Refactor ruthlessly. If you see a piece of code that is garbage, or looks like garbage, or is difficult to read, rewrite it, throw it away. Okay? Always be trying to clean your code as you go. If you find any piece of code that is dirty, and again, by dirty, I mean everything from it's difficult to read, by that I mean you're asking for too much from an argument, and you realize you don't need all that, change the function, make it smaller, update all the references. Okay? Always be cleaning your code. It's like, your code requires maintenance, just like anything else, right? Just like you have to always clean your house, it gets dirty again, you have to clean it again. Same thing with code. Always be cleaning your code as you go, always. The moment you stop, it's going to get dirtier and dirtier and dirtier and then turn into garbage. Rewrite bravely. Don't fall in love with your code. So again, and I say this all the time, I've thrown away most of the code I have personally ever written. Just thrown it away. Either because I rewrote it, or because I wrote it just to learn something and then threw it away. Whatever, okay? Your code is not that important. What matters is the result. Okay? So write code, that's fine, but if you find a better way to do it, or you find that the code you wrote is not clean, or you find a better implementation, or you find a library that does it and does it better, throw this away, put that in its place. Okay? Don't be afraid to throw code away, it's okay. I know. It's okay. And so lastly, guys, so this is, it pains me to say this, but this will be the last meeting for this set of meetings, okay? It will not be actually our last meeting. We will meet again. I promise you that. In what contexts, in what kind of environments, I don't know. I'll be going to, there's a development meetup I know that some of the engineers are organizing that I'll be trying to attend because I want to learn stuff as well. I'm going to be part of the community, so I'll be always around. My email address is, pardon, I don't mean to make my name that big, but just so that you guys can get my email address, is rmeschian@gmail. Find me on Facebook and LinkedIn. Don't think that because it's over that the lines of communication are cut. Okay? I'm still here. Even if I'm not in Armenia, I'm still here. Email me, ask me questions. I'm always ready and very happy to help. It's been an absolute pleasure speaking with you guys, and I hope to see you very soon. Thank you so much. Very quickly, VMware and another company here, Crossroad, that got some flyers. If anyone's looking for work, some new opportunities, they're right here. Just think about it and see what you think. Take care, guys. Bye-bye.
Ժողովուրդ ջան, այս ֆլայերների վերաբերյալ եթե հարցեր կան, խնդրում եմ մոտեցեք հարցրեք Crossroad-ի վերաբերյալ։ Մենք շատ լավ ծրագրավորողներ ենք փնտրում եւ ամենակարևորը, եթե դուք ունեք հումորից զգացում, պայման դիպ։ Կարտադիր
Все, бать, я не хочу. Ай, как,
Web դիզայների համար կարող եք դիմել Rouben, որ արի ես։
Ահա